Let's talk about your computer's greatest magic trick. I mean, think about it. Right now, you might have music streaming, a bunch of tabs open, maybe a file downloading, and it all just works. So, how? How does it do that? We're going to pull back the curtain and look at the incredible, invisible choreography that's happening inside your device every single second. Right. This is the core question, isn't it? It really feels like your computer is a master multitasker, doing everything at once. But here's the secret. It's not. It's actually an illusion, a brilliant one. It's not about doing everything at the same time, but about switching between tasks so mind-bogglingly fast that it just seems like it is. And the secret sauce? It's all managed by your operating system. So, to really get our heads around this, we're going to use a simple analogy that makes it all click. Just imagine your computer's operating system. You know, your Windows, your Mac OS, whatever. Imagine it's the manager of a massive, super busy office building. Every single program you run is like a whole department in that building. Okay, so let's start with the big picture here, the departments themselves. In the world of computers, we don't call them departments, we call them processes. A process is really just a program that's up and running. So your web browser, that's one process. Your music app, that's another. And just like the sales department has its own budget and its own team, each process gets its own chunk of memory and its own resources. And here's the really important part. They're isolated. What happens in sales stays in sales. That's why when one app crashes, it usually doesn't bring your entire computer down with it. Pretty neat, right? And every single one of these processes has a life cycle, kind of like a project at work. It starts as new, that's the hiring phase. Then it becomes ready, basically sitting in the lobby waiting for the boss to give it something to do. Running means it's actively using the CPU, really getting work done. Waiting is like being stuck, on hold for a report from another department. And finally, terminated. Project's over, job done. See? It all makes sense. So, how on earth does the operating system keep track of all these different departments, all in different states? Well, it uses something called a process control block, or PCB. The best way to think of this is like an official company ID card for every single process. It's got all the vital stats the OS needs to manage everything. Now, what's on this ID card is what's really cool. You've got the process ID, that's its unique employee number. You've got its current state, is it running, waiting, what's it doing? The program counters, like a little bookmark that tells the CPU exactly where it left off. And the CPU registers, that's the short-term memory, the stuff it's working on right now. When the OS needs to switch tasks, it saves a snapshot of all this to the PCB, so it can come back later and pick up right where it left off without missing a beat. Okay, so we've got our departments, the processes, but what about the actual work happening inside those departments? For that, we need to zoom in a little bit and talk about threads. A thread is the absolute smallest piece of work the CPU can handle. In our office analogy, if your web browser is the marketing department, then one thread might be loading images, another thread is playing a video, and a third is listening for your mouse clicks. They're all the individual employees working on different things, but they're all part of the same team, sharing the department's resources, the office space, the files, and yeah, even the coffee machine. And this right here really nails the difference. Creating a whole new process, a brand new department, is a big deal. It's heavyweight. It takes a lot of time and resources to set up. But creating a new thread, that's just like hiring a new employee for a department that's already there. It's way faster, way more efficient, it's lightweight because they just use the resources that are already available. And this is exactly why modern apps are built on threads. You know when you're doing something heavy in an app, but the interface doesn't freeze up? You can still click buttons. That's thanks to threads. And if you have a multi-core CPU, different threads can literally run on different cores at the exact same time. That's true parallelism. It is just a much, much smarter way to get things done. So now we've got hundreds of processes, maybe thousands of threads, all of them shouting, me next, wanting a piece of the CPU's time. This sounds like a recipe for absolute chaos, but it isn't, all thanks to one critical, unsung hero, the scheduler. Back in our office building, the scheduler is the hyper-efficient office manager. Its one and only job is to look at all the employees ready to work and decide who gets to see the boss, the CPU, next, and for how long. This constant, high-speed decision-making is what keeps your entire computer from grinding to a halt. And this office manager basically has two ways of doing things. The first is non-preemptive. That's the polite manager. Once an employee starts a task, they get to finish it, no interruptions. It's simple, but it's not great for that feeling of responsiveness.
Modern systems like the one you're using now are preemptive. This manager can and will interrupt an employee mid-task to say, hey, stop what you're doing, the CEO has an urgent request. It's more complex, but it's what makes everything feel so fast. To make these split-second decisions, our manager uses a playbook of rules, or algorithms. First come, first served is exactly what it sounds like. Simple, but if a really long job gets in first, everyone else has to wait. Round robin is much fairer. It's like saying, okay, everyone, you each get exactly 2 minutes with the boss, then it's the next person's turn. Then there's priority, where the most important tasks, the CEO's request, always get to jump the line. The trick is, if you do that too much, the low priority tasks might never get their turn. It's called starvation. Each one of these is a trade-off.
Okay, so we've talked about departments, employees, and a very busy office manager. We've gone kind of deep here. But why does any of this invisible technical stuff actually matter to you?
At the end of the day, it's everything. This invisible dance is the reason your device feels so powerful. Every time you switch apps without a thought, every time a video plays smoothly while something else is happening in the background, you are experiencing the result of this perfectly choreographed ballet. It's the magic that lets a single processor act like it can do a million things at once.
And you know, sometimes this isn't just about convenience. Sometimes it's literally a matter of life and death. In systems like a pacemaker or the anti-lock brakes in your car, a task doesn't just need to get done, it has to be done within a strict, unmissable deadline. That's called real-time scheduling, where being on time is just as important as being correct. So the next time you use your phone or computer and it feels instantaneous, just take a second. Appreciate the magic. Because it's not one big brain doing everything at once. No, it's a lightning-fast office manager directing thousands of tiny employees, switching between them millions of times a second, all to create that seamless experience you're having. And that is the invisible dance.